Welcome to The Explainer. Today we're diving into something absolutely massive. It's so intricately woven into our daily lives, yet, it's largely hidden right in plain sight. Just think about it for a second. How does energy actually travel from deep underground all the way to the burner on your stove or the gas tank in your car? It is a colossal journey. We're talking millions of miles of steel, incredibly complex chemistry, and global shipping routes. But with a physical footprint that massive, a really huge question pops up. How do we keep track of its sustainability? How do we actually measure the risks involved?
So let's kick things off by defining exactly what part of the energy world we're zeroing in on today. The midstream industry is essentially the ultimate middleman. It's not the companies out there drilling the wells, that's the upstream side, and it's not your local gas stations or utility companies selling to you, that's downstream. Midstream entities are the ones transporting, storing, and processing natural gas, crude oil, and refined petroleum products. They're literally the arteries connecting the wellhead to the wider world, and they do it using an insane network of pipelines, trucks, rail cars, and massive marine tankers.
To really wrap our heads around this, let's visualize the exact physical journey of natural gas in a 3D space. First up, we've got gathering. This is collecting the raw natural gas directly from the wellhead. Next, it moves into processing. This step is absolutely crucial because it involves the removal of impurities and the production of valuable natural gas liquids, or NGLs. Then, if this gas needs to cross an ocean, it undergoes liquefaction. It's chilled down and turned into LNG, so it can be loaded onto these massive maritime ships. Finally, it hits its destination for transport and regasification, basically turning back into the gas that heats our homes. It's just a remarkably complex, highly engineered sequence of events.
Now, visualizing that unbelievable physical scale naturally brings us to a pretty essential question. Pose this to yourself. How do we actually measure the impact of millions of miles of pipeline and all of those processing facilities? Because when you're running a vast network of marine transportation, pipelines, trains, and trucks, you're carrying considerable risks, both to the environment and to local communities. We really need a standardized way to hold this massive infrastructure accountable.
And that is exactly where the SASB standards come in, which are now under the stewardship of the International Sustainability Standards Board, or the ISSB. You can think of this document, specifically the EMMD standard for oil and gas midstream, as the ultimate sustainability ledger. It gives us a standardized, metrics-driven framework. It requires companies to disclose exactly how they're managing all these sustainability-related risks and opportunities. To make sense of this massive ledger, the standard breaks the industry down into 5 pillars: greenhouse gas emissions, air quality, ecological impacts, operational safety, and competitive behavior.
Pillar 1. Tracking greenhouse gas emissions, focusing on methane and Scope 1 impacts. The crucial takeaway here is understanding what Scope 1 emissions actually are. These are the direct greenhouse gases emitted right into the atmosphere. The SASB standard requires companies to track 7 specific greenhouse gases that are covered under the Kyoto Protocol, and they measure them in metric tons of carbon dioxide equivalent. For midstream companies, these direct sources aren't just stationary equipment at terminals and refineries. They also include mobile sources. So we're talking about the marine vessels transporting products and their massive tank truck fleets.
But hey, it's not just about the exhaust billowing out of a massive ship engine. The standard also mandates the tracking of fugitive emissions. We're talking about those unintentional, tiny leaks coming from valves, flanges, connectors, pumps, and compressor seals. And why does this matter? Well, because methane is a highly potent greenhouse gas. 1 million tiny leaks scattered across 1 million miles of pipeline? Yeah, that adds up incredibly fast. The goal here is to individually find and fix these to drive emissions down to near zero. Moving to Pillar 2, local air quality, looking beyond the global climate impact. What's really fascinating here is the precise level of chemical tracking they demand. The ledger requires hard data on 4 specific pollutants, all measured in metric tons. You've got NOx and SOx. These are the culprits that contribute to smog and acid rain. Then you have VOCs, or volatile organic compounds, which get involved in atmospheric photochemical reactions. And lastly, PM10. This is finely divided solid or liquid airborne material that's 10 micrometers or less in diameter. That means it's small enough to be inhaled deep into your lungs. So yeah, this is rigorous, highly specific tracking.
Pillar 3. Ecological impacts and the physical footprint on the land.
Remember, this whole industry relies on pipeline rights-of-way and open easements that literally cut straight across the physical landscape. Running vast networks of steel through nature obviously presents considerable risks, like natural habitat loss and disrupting how local wildlife naturally moves through the terrain.
Because of this, the SASB standard actually forces companies to calculate the percentage of their owned, leased, or operated land that sits right inside areas of protected conservation status. And let me tell you, the criteria are strict. We're talking about land that overlaps with UNESCO World Heritage Sites, Natura 2000 sites, Ramsar wetlands of international importance, and habitats where critically endangered species are extant, meaning they live there, breed there, or even just pass through on normal migration routes.
And it's not enough to just report if a pipeline cuts directly through an endangered ecosystem. Proximity matters here. Under these metrics, a habitat is considered near if it's within 5 kilometers of the boundary of the entity's facilities or operations. That means companies have to actively monitor and report on these surrounding buffer zones, making sure their ecological footprint is tightly managed.
Pillar 4, Operational Safety and Emergency Preparedness, aimed at preventing disasters and system failures.
Operating a sprawling network full of highly combustible, pressurized material means the risk of spills and accidents is just an ever-present reality. Having a rock-solid safety culture and a systematic approach to risk management isn't just nice to have, it's absolutely essential. To really grasp how tightly safety is monitored, just look at this number, 19. If there's a failure in a pipeline system that releases just 19 liters of hazardous liquid in transit, it becomes a reportable incident under certain conditions. 19 liters. Even a release that small has to be reported if it isn't cleaned up promptly, if it escapes the company's property, or if it hits a stream, river, or lake and violates water quality standards. Accountability literally starts at the micro level.
Now I want you to contrast that 19 liters of liquid with this massive scale, 85,000. For gas transmission, gathering, and distribution, an unintentional estimated gas loss of 85,000 cubic meters, which is roughly 3 million cubic feet, is the threshold that actually marks a reportable incident. The sheer volume difference between the liquid and gas metrics really highlights the incredibly varied nature of the materials this industry is handling day in and day out.
Safety tracking also extends right out onto the railways. Companies are required to report releases of hazardous materials from rail transit, but they have to split that data into 2 very different categories. On one hand, you have sudden, catastrophic accident releases. These are caused by major events like train derailments or collisions. But on the other side, you have non-accident releases, or NARs. These are those slow, systemic issues we talked about earlier. Things like splashes during loading, leaks from improperly secured fittings, or defective valves. Both sides demand strict management, but they require entirely different safety strategies to fix.
Finally, Pillar 5, Competitive Behavior and Regulating Natural Monopolies.
The midstream sector is pretty unique in how it interacts with the broader market. Because pipelines are so incredibly expensive to build, many of them enjoy what economists call a natural monopoly. Think about it. You don't exactly have 5 competing pipelines running to the exact same facility, right? So to ensure companies don't abuse that massive market power, the SASB standard actually requires them to track and disclose total monetary losses resulting from legal proceedings. We're talking cases related to price gouging, price fixing, or discriminatory pipeline access. It's all about keeping the marketplace fair.
So we've traveled all the way from the wellhead, through the massive processing facilities, and right down into the legal ledgers tracking fair competition. By forcing companies to measure everything, from a tiny 19-liter spill to a 5-kilometer ecological buffer zone, the SASB standards act as a deeply powerful tool for accountability. I really want to leave you with this provocative thought to chew on. How does standardizing transparency today fuel a safer, more sustainable energy infrastructure for tomorrow? Because at the end of the day, when we measure the impacts, we can finally begin to manage them. Thanks so much for joining me on this explainer.